Hello friends, welcome back to Get Up. My name is Vikas. In my previous video lecture on engineering mechanics, we have studied what is a force and what are different kinds of forces and also the system of forces. Okay, so I hope you have gone through my previous video lecture, because today we are going to apply those concept of forces and system of forces to find the unknown forces with the help of free body diagram. Okay, so free body diagram is used to find the unknown forces acting on a body. Okay. And also we'll finding how these forces are in equilibrium, what is the condition for equilibrium of forces acting on a body. Okay, so this is a concept which is not directly asked in the GATE exam in your questions, but that concept is asked indirectly in the questions. Okay, so this is very important. Now as you know, the engineering mechanics is a mechanics of rigid body. So in this rigid body we are going to study internal and external forces, free body diagram, principle of transmissibility, moment or couples acting on the body, force couple system on the rigid body, and rigid body equilibrium. Okay, so these are some things that we are going to understand, and these are some concepts related to rigid body analysis. Okay, in today's video lecture we are going to study free body diagram or free body of forces in equilibrium acting on a body. It is almost same. To find the forces in equilibrium on a body and free body diagram is the same thing. Okay, let's see what it is actually. Okay, so before understanding that, we should understand for a rigid body what are external forces and what is internal forces. So as I told you in the introduction part of the engineering mechanics lecture, that there are different kinds of forces acting on a body. Okay, and in the rigid body we are only interested in finding the external forces. Okay, so external forces represent the action of other bodies on the rigid body. Okay, it is entirely responsible for the motion of the rigid body as described by Newton's law of motion. Okay, so external forces are the forces which are acting on a body by this force is acted by some other body on the given body. Okay, so it is the effect of some other force, other body, and it is basically due to contact force. Okay, external forces are basically contact force or push and pull forces. Okay, and you can also say friction force is also kind of external force. Okay, but this is due to reaction to the or resistance to the motion. Okay, so it is also a type of contact force. So all the kind of contact forces come under the external forces. Okay, now what about the internal forces? Internal forces are the forces which holding the individual particles of a rigid member together. Okay, and the best example of an internal force is the tension force. Tension force, which is commonly seen in cables, strings, and ropes. Okay, so these are some mechanical linkages in which you will see this tension forces, which is a kind of internal force. Okay, and all the external forces act on a rigid body, which is the effect of some other body imparting some force on the rigid body which is under analysis. Okay, now what is the free body diagram? Free body diagram is necessary to investigate the condition of equilibrium of a body. Suppose that there is a body which is placed in a system, placed at a place. Okay, for example, this is a block. This is a block which is kept on a horizontal surface. This is a surface. Okay, this is just kept on a surface. Okay, now we have to do analysis of what are different kind of forces acting on this block. Okay, so this is a block which is kept on a ground. Now you have to analyze what are different kinds of forces which are acting on this block. Now this, as you know, that even if this block is stationary, there will be a gravitational force which will be due to weight. Weight will be equal to m into z, and this weight will be acting toward the center of mass of the center of gravity of the body. Okay, and there will be a normal reaction to this weight. Okay, so this, you know that even if the body of this block is stationary, then also these two forces will be acting. Okay, now suppose that there is a force which is applied to move this block in this direction. Okay, now due to this movement there will be a resistance force which will be acted. Okay, which will try to resist this motion. This will be a friction force. So if you analyze this block, there will be a normal force there will be a weight, there will be a normal force, there will be a force due to motion, okay, and there will be a frictional force. Okay, so this is a free body diagram of this block. Okay, now while drawing the free body diagram, all the supports of the body are removed and replaced with the reaction acting on it. Okay, so let's see what kind of supports are there. Okay, again there is a free body diagram of a rigid body, okay, in which you can see there is a truck and some people are pulling this truck with a force F. Okay, they are applying a force and they are trying to pull this truck towards itself. Okay, now if you want to draw the free body diagram of this truck, so you know that there is some weight of this body truck which will be acting downwards, okay, toward the center of the gravity, and there will also be a force which is being pulled by these three persons. They are pulling this truck. Okay, now if you see these supports, these are called supports. Now in the free body diagram analysis, what you need to do is you need to remove these supports and you need to find the unknown forces or unknown reactions. As you know that by Newton's third law of motion, every action has an equal and opposite reaction. So these supports are imparting some force on the earth. Okay, so they will receive a reactionary force from this earth. Okay, that reaction force, suppose this is R1, this is R2. Okay, so this is the free body diagram. Okay, so the free body diagram of this truck is like this. Suppose this is a truck. Okay, there is a mass or weight acting downward. Okay, there will be a reaction of this roller, this tire, and there is a reaction from this tire R2. Okay, and there also be a normal reaction. Okay, so this is a free body diagram of this truck. Okay, so the idea is that all the supports will be removed and the unknown reactions that are that act due to those supports will be, we have to find those unknown reactions. So you have to find the value of R1 and R2, okay, in the free body analysis. So what are the steps in making the free body diagram? Okay, the most important part of making a free body diagram is to make a clear decision between on which is the body on which your analysis need to be carried out. Okay, suppose that if you are sitting on a chair, suppose if you are sitting on a chair, and so what is the body under analysis? Is it your chair with person, which is the body which you need to analyze, or it's the person only which on which free body diagram analysis is need to be carried out? Okay, suppose that if I am doing the analysis on a person plus chair, okay, so there will be a weight of this chair, okay, and then because if a person is sitting on this chair, okay, so all the weight of the person will be carried out by the chair. So there will be weight of the this combined weight, okay, and then there will be a reaction by this there will be a reaction force, and there will be also reaction by the these 2 feet of the chair, okay, reaction by the feet along with the reaction of the supports of the chair. Okay, this is a free body diagram of the person plus chair. So if you need to draw the free body diagram of person and chair both, then this will be the free body diagram. Okay, but if you need to draw the free body diagram of the person only, okay, so there will be a weight of the person, okay, there will be a reaction force of the chair, and there will be a reaction force of this feet of the person. Okay, so this is a difference. If for drawing a free body diagram, the one thing that need to be you need to decide is that what part of the space diagram or system you are analyzing. Okay, so if the analysis is need to be carried out on the person plus chair, so this will be the free body diagram, and if the analysis is to be carried out on the person only, so this is the free body diagram. So you need to make a clear distinction between what is the body on which your analysis is carried out. Okay, now what are the steps to draw free body diagram? Firstly, you have to imagine the body isolated from the surrounding. Okay, suppose that you need to draw the free body diagram of the person only, so you have to isolate this chair. Okay, you don't have to think that there is a chair. Okay, you just need to draw the free body diagram of this person. Suppose this is a person. Okay, so there will be a weight of the person. Okay, there will be a reaction from this reaction from his feet, also reaction from the chair, and also there will be a normal reaction. Okay, so this is a free body diagram of the person which is sitting on the chair, and we are only analyzing the person. Okay, so you have to imagine the body isolated from the surrounding. Okay, then you have to show all the forces and moment. Okay, so you have to show all the forces. So you are saying that this is a force which is acting, okay, and this is the reaction force, and this is the weight. Okay, so you have to show all the forces then, and finally you have to place each force and couple at the point at which it is applied. So you have to place the forces and the reaction and the couple at the point of the application of the force. Okay, now what are the different kind of forces? If you see the analyze the free body diagram, so they are external force vector. Okay, external force vector represent the forces acting on the free body by the surrounding. Okay, so the forces which are imparted by the surrounding on the free body, okay, those are called external force vector, and these are very important. Okay, and they must be applied to the body where they are acting on the body. Okay, suppose that in this example, the external forces are acting on this body. Okay, these are the external forces. Okay, and this is also external force. So this force is the external force of the surrounding on the body. Okay, so you need to put those forces on at the point of application of the body. Okay, so at the point at which these forces are acting on the body, you have to put these forces at those points. It must be represented with direction, magnitude. You have to represent the forces with the direction. Direction is very important, because if the weight is acting downward and the normal reaction is acting upward, and the force is acting this side and the resistance will be acting this side. So you need to analyze the forces and the direction also. If the direction is wrong, if your analysis is done and the direction you have taken is wrong, so the whole analysis will be incorrect. Okay, you will not be able to find the correct answer. So the one thing that is important is that you should give a clear right direction and magnitude of the force. The weight of the object applicable should be placed at the center of gravity. So weight should always be kept at the center of gravity of the body. Okay, now there are different kind of reaction force. Okay, as you know that there are different kind of supports, and those supports used to offer a reaction force on the body. So what are different kind of reaction? Unknown external forces are known as reaction or constraining forces, and they must be shown on the free body diagram. Okay, so if there are any kind of reaction acting on the body, those reaction must be shown on the free body diagram. A reaction and the forces that constrain one or more degree of freedom of the motion and must be indicated on the free body diagram. So why do we need a support? Suppose that if you are sitting on a chair, okay, so if they are not two supports, okay, and or there are four supports, so they just need to restrict the degree of motion. Okay, otherwise you will get fell down. Okay, if they are not supports, so their supports are just need to make you stable. Okay, along with that they offer a resistance, and they are used to constrain the degree of motion. Degree of motion means the motion in which the body can move. Okay, so suppose that if your chair on which you are sitting is not having this reaction, okay, so this chair will be moving along this direction. Okay, so if all the supports are there, all the four supports are there, then this chair will be stable. So their supports are used to restrict the degree of motion or the movement in which your body can move. Okay, so this is very important, and those reactions are always you need to use those reaction for analysis of the free body diagram. Okay, so let us see what are different kind of external forces acting on a body. Suppose that there is a rope or cable, or there is a spring. Okay, so rope, cable or spring, these are all extensible part of mechanical component which are extensible. Okay, so these are used to offer a reaction. Suppose there is a rope or cable, so rope or cable we offer a tension force. Okay, because the rope and cable, the reaction force due to this rope or cable will be a tension force. Okay, which will be opposite in direction. Okay, so suppose there is a rope or cable or a spring, so the reaction force of the rope, cable or spring will be acting in the opposite direction of the motion. So this will be the reaction force, and this reaction force in a rope, cable or string is called tension force. Okay, again there is a contact with a smooth surface. Suppose your body is contacting a smooth surface. So there will be a reaction by this smooth surface. That reaction is called normal force, which will be acting at the supporting surface. Again, if it is a rough surface, so there will be two reactions. One reaction will be in the horizontal direction, one in the vertical direction. So always remember, if there is a rough surface, okay, so there will be two reactions. But for our analysis in a rigid body engineering mechanics, we always assume that there is a smooth surface on which your body is kept. So there will be only one normal reaction. So this is the reason why always, if your weight is acting this direction, your normal reaction is there is only one normal reaction. Okay, there are not two normal reactions, or there are not two reactions. The reason is that we assume that the body on which the surface on which our body is kept is a smooth surface. Okay. If it is a rough surface, then there will be two force components. Now, if it is a pin support, if you have pin connected support, then there again there will be two force components. Okay, in the horizontal and vertical direction. If there is a roller support, if there is a kind of roller support, then there will be only one normal reaction force which will be acting at the point of the roller support. If there is a constrained pin or a slider, okay, then again there will be a normal force. So you just need to remember it. Then if it is a roller support or a pin support or a constrained pin or slider support, so there will be a normal force after removing that support. Okay. And if it is a fixed support, for example, there is a fixed support. If your body is fixed to this support, okay, so then there will be one horizontal component of the force. There will be a reaction, and there will be a moment, or there will be a couple which will be acting here. Okay, so there will be two force components in a couple. Okay, what is a couple? I will be telling you now. Firstly, we should understand what is the principle of transmissibility. Principle of transmissibility is the condition of equilibrium or motion of a rigid body that will remain unchanged by moving a force along its line of action, provided the force magnitude and action does not change. So if we are suppose there is a force acting on a body, okay, and the force is acting in this line of action. Suppose this is a force which is acting here. Okay. So condition of equilibrium or motion of a rigid body will remain unchanged by moving a force along its line of action. So if this is a line of action of force. So if we try to move this force along this line of action, so the force equilibrium condition will remain unchanged. Okay, so equilibrium condition will be same. Okay, so this is the principle of transmissibility. And what is the equilibrium condition? Equilibrium condition says that the net forces acting in a direction is equal to 0. Okay, so if there are suppose there are three forces acting in this direction. Okay, and if so the net forces F1 plus F2 plus F3 in this direction will be equal to 0. So this is called condition of equilibrium of forces. Okay, so if there are different forces acting in X, Y and Z direction, so condition of equilibrium will be equal to Fx is equal to 0, Fy equal to 0 and Fz equal to 0. So this is condition of equilibrium of forces. Okay, that the net force acting in a given direction is equal to 0. So if you see equilibrium of rigid body, okay, so the net force, as I told you, the net force acting in a direction, summation of all the forces acting in a given direction is equal to 0, and also the summation of moment acting in a given direction is equal to 0. So to draw free body diagram, you need to replace the support with all the reactions. So as we have seen that table, if for different kind of support, there are different reaction. Okay, for example, for a roller support there will be only one reaction. For a built fixed support there will be two reaction and a couple. Okay, so you need to remember that what are different kind of reaction which will take place after removing the support, because for a free body diagram you have to find the unknown reactions. Okay, otherwise your calculation will be incomplete. So for a free body diagram there are different components. The first component is a force. Now force is force is external force or can be internal force. The external force is a push or pull force which is acting upon by a object, and it has both direction and magnitude. Okay, so the force which is acting on a body for a free body diagram analysis, that force is having a magnitude, along with that a direction. Okay, direction is very important. Okay, because our calculation of free body diagram, if your direction is not correct, then you will not get the correct answer. Okay. Next thing is called moment. Now what is a moment? Suppose that is a body. Suppose there is a rigid body. Okay, this is a rigid body. And suppose there is a point A. Okay, and at this point there is a force F1 acting here. Okay. Now if I am trying to find the force at this point B on the rigid body, so I will be replacing this force F1 with two equal and opposite forces, okay, at this point B, and which will be equal to this force F1. Okay. Now what will happen? These equal and opposite forces at point A and B will offer a moment. Okay, this moment will be something which will try to rotate this rigid body about these points. Okay, so this moment is equal to, suppose this is a distance d, perpendicular distance between line of action of the forces at point A and B is d. Okay, so this moment will be equal to F into d, F1 into d, where F1 is the force and d is the perpendicular distance between the line of action of the forces between point A and B. Okay, so this moment will be the product of F1 into d, and this moment is also called as couple. So the net reaction at this will be equal to, what is the net force? There will be net force of F1 at point B, and there will be a couple M equal to F1 into D. Okay, so these equal and opposite forces will make a couple, okay, or moment. So this is a concept of the moment. This is a twisting effort about a point or axis when a force is applied at a distance. So whenever a force is applied at a distance, so that will offer a moment, and that moment will be the product of the force and the perpendicular distance between the line of action of the forces. Okay. So if the force is acting in, moment is acting in this direction, this is clockwise, and this is anti-clockwise. Okay, so this moment is either in clockwise direction or anti-clockwise direction. So if you want to take clockwise direction as positive, so this moment will be positive, and anti-clockwise you can take negative. So it's up to you what sign convention you take, but this is a concept about the moment. Okay, it is a product of force into perpendicular distance along the line of action of the force. Now if we see, if you draw a free body diagram for a truss, okay, so truss is, you have seen the example of truss in different kind of bridges, and for the best example of a truss is a bridge. Okay, so if you see a bridge and analyze a bridge, so there are different members which are used to join by different supports. Okay, this is how a bridge is made. Okay, there are different supports, there are different linkages. Okay, suppose this is a truss. Okay, now this is a truss is a structural member or a structural component in which there are different joints, and these joints are used to give a support. Okay, and the best example of a truss is a bridge. Okay, so suppose this is a truss and this is giving two supports. There's a one support which is a fixed support, simply supported here, and there is a support, a roller supported here. Okay, there are two supports given. There is a pinpoint support and there is a roller support, and there is also a weight acting at this point V. Now if you need to draw the free body diagram, why you need to draw the free body diagram? Because you need to find the unknown forces acting on this truss. Okay, so to draw the free body diagram, since this is a kind of support, this is which kind of support? As you see, as you have seen here, this is a pin support. So for a pin support, as I have told you, there will be two reactions. One will be a horizontal direction, one in the upward direction. So since in this truss, this is a pin support, so there will be two reactions, one in the horizontal direction, one in the vertical direction. And since this was a roller support, so there will be only one reaction. Okay, and there will be a force which is acting point B. So this is the free body diagram of a truss. Okay, so this is how we will be finding the unknown reactions on a given body. Okay, and this is nothing but free body diagram. Now let us see free body diagram of different components. Suppose there is a surface on which there are two blocks. Okay, block A and block B. Okay, so if we need to draw the free body diagram of this two blocks, how we are going to draw it? It's very simple. Suppose that this block is also moving. Okay, the block is also moving. So there will be a reaction force to this block, which will be equal to F, okay, and this friction force is equal to mu into the normal reaction. So there will be a weight mg, okay, and there will be a normal reaction n, okay. So if we need to draw the free body diagram of this block B first, which is acting, which is kept on the block A. So the free body diagram of this block A will be, there will be a normal reaction, okay, there will be a weight W, which is equal to mg, okay, A is for the, mg, and this is for the body A. There will be a force F with which this block is moving, and there will be a reaction force, and this reaction force will be equal to mu into n, okay, and this will be mu into n1, the reaction force, normal reaction to this block A. Now for the block B, this will be equal to mg, normal reaction, okay, and they will, since this is a friction force which is acting for this block A in this direction opposite to the motion, so there will be a reaction force, friction force on a block A also, which will be acting on this opposite direction, mu into n1. So there will be a mu into n1 reaction force. Now if this block B also moving with force F, there will be a reaction force, friction force will be, which will be equal to mu into n2, where n2 is the normal reaction of this block B, okay. So this is how we are going to draw the free body diagram of a given body. Now again, if there is a inclined support and the body is kept on an inclined surface like this, okay. Now this body is having a mass m, okay, and this is making angle theta. The inclined surface is making angle theta with this surface, okay. So this is block A. Now this weight is equal to mg, okay. There will be a normal reaction which will be equal to n. So this angle, by the mathematics, this will be equal to n theta, okay. This angle will be equal to theta. So this will be equal to mg of cos theta. This is nothing but resolution of the forces in two direction, and the horizontal component will be equal to mg of sin theta, okay. And if this body is moving in this direction, block is moving in this direction, this is force F. So there will be a friction force which will be equal to mu into n, okay. So if you draw the free body diagram in x direction, y direction, so free body diagram in x direction will be equal to n, y direction will be equal to n minus mg of cos theta equal to 0, okay. And for the x direction, this will be equal to f minus mu into n minus mg of sin theta equal to 0. So this is nothing but condition of equilibrium for the free body, summation of fy equal to 0 and summation of fx equal to 0, okay. So I hope this is clear to you. And then in the end, we see the example of a pulley. There is a fixed pulley which is fixed over here, okay, and this is having two weights, m1 and m2, okay. Now as you know that this pulley system is held with the help of these cables, okay, and this pulley is supporting two weights with the help of these cables. Now this cable will offer a tension force. This tension force will be just opposite to a direction motion. This will be T, and there will be a weight of reaction, okay. Now to draw the free body diagram of this weight m1, suppose I want to draw the free body diagram of this weight m1. Now we assume that, initially we assume that this weight m1 is moving in this direction, okay. So there will be acceleration in this direction, okay. There is a force F which will be equal to m1 into A, okay, where A is the acceleration. So we'll assume that the block A is moving, m1 is moving, block having mass m1 is moving in this downward direction, okay. Now what will be the free body diagram for m1? This will be equal to m1 into g, okay. There will also be a force m1 into A acting in this direction. There will be a tension force acting in this direction, okay. This is the free body diagram of this, okay. So the concept is that the net external forces is equal to m into a. Okay, so the external force acting is equal to T minus mg will be equal to ma. Now after calculating the value of a acceleration, if this acceleration is positive, okay, then the this pulley system will be acting downward, okay, and this will be acting upward. M2A will be acting upward. Okay, so this is a free body diagram of mass m1. So the free body diagram of this pulley system will be equal to, this is a free body diagram of pulley. Okay, the total tension force is equal to 2T at this pulley, and the assumption that we assume for this pulley arrangement is that this is massless and these cables are inextensible. Okay, so this is a different cases that we have studied, that two blocks are placed on a horizontal surface, and we have drawn the free body diagram of these blocks. If a block is kept on a wedge type surface or inclined plane, then this will be the condition of equilibrium of forces. Okay, if there is a pulley system, okay, then this will be the free body diagram of the pulley and the mass. Okay, and this is how, if you will be able to distinguish that what will be the direction of motion of this mass. If the net external force acting is equal to m into a, if the acceleration is positive, so the motion of this pulley system will be acting downward, and the sign convention is correct. If it is negative, then this will be acting upward and this will be acting downward. Okay, so this is how you will be able to find the unknown tension or unknown forces with the help of a free body diagram. Okay, so this was a concept on free body diagram and the condition of equilibrium of the forces. Okay, so the main idea is that free body diagram is used to find the unknown forces acting on a body by analyzing the body which is under studied or under consideration of the study. So for free body analysis, one thing that is important is that the body which is under consideration for study, you should concentrate on that body. You should replace all the support with the reactions. Okay, and those reactions, for example, you should understand that if it is a pin support, there will be two forces or two reactions. If it is a roller support, there will be one reaction. If it is a fixed support, then it will be two reactions. So you need to understand it. Why? Because you will be using those concepts. Okay, the application of free body diagram is in the trusses and frame, and that topic will be studying in the next video lecture, in which you will be finding the unknown forces in truss and frame. Okay, so this is for today. In the next video lecture, we will be studying the topic truss and frame, and we will finding the unknown forces and reaction and moments on a truss or frame. Okay, so this is all for today. Thanks for listening. Have a nice day. Thank you.